Standard deviation of a sample. The standard deviation is the measure of variation most commonly used in statistics. The standard deviation of a set of sample values, denoted by lowercase s, is a measure of how much data values deviate away from the mean. It can be calculated by using two formulas which are listed below. Okay. The first formula, 3.5, is just a different version of formula 3.4, but it is algebraically the same. Now, the standard deviation found from the sample data is a statistic denoted by the lowercase s, but the standard deviation found from population data is a parameter denoted by this sigma, which is the standard deviation. So the formula for the population standard deviation is slightly different, with the division by the population size, capital N, used instead of division by n minus 1. And we will discuss this population standard deviation later. But again, it's important, just like when we talked about the mean, where we have the sample mean and the population mean, we also want to make sure that we can see the difference between the sample standard deviation and the population standard deviation. So here's your notation. Lowercase s is equal to the sample standard deviation, and the sigma is equal to population standard deviation. So here's the sample standard deviation formula. S is equal to the square root of the sum of the quantity of the data value minus the sample mean squared divided by n minus 1. Now the shortcut formula for sample standard deviation, which is used by calculators and software, would be the following. S would equal the square root of the sample size times the sum of the data values squared minus the sum of the data values, and then squaring that, times divided by n times n minus 1. Now the important properties of standard deviation. The standard deviation is a measure of how much data values deviate away from the mean. The value of the standard deviation lowercase s is never negative. It is 0 only when all of the data values are exactly the same. Larger values of the sample standard deviation indicate greater amounts of variation. The standard deviation can increase dramatically with one or more outliers. The units of standard deviation, such as minutes, feet, pounds, are the same as the units of the original data values. Now, the sample standard deviation is a biased estimator of the population standard deviation, which means that values of the sample standard deviation do not center around the value of the population standard deviation.